Hey guys, this lesson is for Calculus BC, and this is from section 10.2 to 10.3. I kind of combined them together. It is all about parametrics. So in 10.2, I'll remind you about what you learned in pre-cal, and then in 10.3, we'll start talking about the calculus being used to the parametric equations. So to begin with, if you want to see this in my pre-cal videos, the basics, it is from 9.5. I'll go over a little bit of it here. And what parametric equations is that it's a third variable t for time is introduced to the equations, okay? So what you do in parametric equations is you rewrite x and y as their own functions with t as your variable. So x is like we could say f of t and y would be g of t, okay? So we're gonna have two equations here. And then when we graph them, if we put different t's in, the x comma y's that we get will be the ordered pairs to draw my graph. Let's take a look at this example. So it says sketch x with an equation of t and y with an equation of t, and only do so when t is from -2 to 3. Okay, so you're going to create a table with your t from -2 to 3, whole numbers only, and you're going to plug -2 through t into this equation to get your x's, and then into this equation to get your y's. Okay, I've also gone ahead and set it up on my calculator to show you how to work with parametrics on your graphing calculator. So first thing you need to do is go to mode, and down here your calculator is usually on the button function. You're going to scroll over and press enter on parametrics, and then you're going to go second quit to go back to home screen. Now when you go to your y1, notice that instead of y1 through whatever, it says x sub 1 of t and y sub 1 of t, and then it goes on to different ones. Okay, so now in my x equation, I put t squared minus 4, and then in my y1 equation, I put half of t. Now the way you put the t in is the same way you put your x. Notice on that button with the x, there's more variables, and the next one is t for when you're in parametric mode. Okay. Now, instead of going to graph, because I want to fill out my table first, I'm going to go ahead and click on top of graph. It says table. So I'm going to press second, graph, and there's my table. It usually starts at 0. If you want to see more numbers, you just scroll accordingly, okay? So I want to go, from -2 onto 3. So here are my x values that I'm going to fill in here, and my y values that I'm going to fill in here. I'm going to take a moment and do that. All right, so I've put my numbers on my chart, and now this x comma y, 0 comma -1, is going to be the first point that I plot. Then -3 comma -1/2, the next point I plot, and so on and so forth. I'm going to take a minute and do that on this graph. So I've gone ahead, plotted the points, and connected the dots. Now the whole point of parametric is that we're introducing that variable t, which stands for time. So this graph represents the direction that an object is going. Okay, so one little thing I'm going to add is that if -2 was my first time, and that was 0, -1, this is where my graph starts, and then it goes in this direction and ends over here, which was the point that I got from 3, the end of my time. So I can just draw little arrows to indicate the direction of this graph. You don't have to do too many. And that's it. That's how you sketch a graph of a parametric equation. The next thing I want to remind you of from pre-cal is how to eliminate the parameter, which is a fancy way of saying that you're going to convert back to an equation of just x and y. So the way you do that is you're going to pick one of the two equations, isolate t, and then plug it into the other function where the t is. Okay? So check this out. If I look at this one, I see I have two t's. It's going to be harder to isolate the t here. And here I only have one of them. So I'm going to work on isolating this one. I'm going to start by cross multiplying. I'm going to divide that x over. Now I'm going to square both sides. Remember, my goal here is to get rid of everything and isolate that t. So now here I end up with t plus 1 equals 1 squared is 1 and x squared is just x squared. And then I'm going to subtract the 1 and say 1 over x squared minus 1. Now that I have t isolated, I'm going to grab this function and plug it into this equation. So y is equivalent to, well, if in the numerator I have 1t, I have to plug all of this in for that spot, over t, which is 1 over x squared minus 1, and then I have a plus 1 here. All that's left now is to clean this up a bit. So here I can drop my parentheses and cancel those 1's out. So I have 1 over x squared minus 1 divided by 1 over x squared. I can keep change flip here. I'm going to multiply by that reciprocal, because if I say divided by 1 over x squared, I'm going to be able to flip this one here. And then I'm going to come up here, and I'm just going to distribute that. So I'd end up with x squared over x squared minus x squared over 1. Just distributed that to both terms. And now I can clean that to say 1 minus x squared. Okay? Or if you're used to having things in order with highest exponent, we could say negative x squared plus 1. And we eliminated the parameter. Now we have one equation in terms of x. For the next style of question, I'm just going to ask you to do the reverse. I'm going to give you a regular equation, and I'm going to tell you to come up with a set of parameters, a parametric equation. So this, believe it or not, is so much easier, and there are so many different ways you could do this, okay? The simplest way is to just replace the x with t and let them know that x is equal to t. I know, you're like, why are you making me do this if this is so easy? If you ever needed to convert to parametrics, I can say, okay, if I'm going to call xt, then I could say y equals 1 minus t squared. There you go. You have a set of parametrics. Another example you could do is say, what if I replace the x squared with t? And then I call this one y equals 1 minus t. This works too, as long as you isolate the x. Then you would have to clean it to say x equals square root of t and y equals 1 minus t. As long as you have an equation for x, an equation for y, you're good. Okay, this is not complicated. This is really easy. You're just creating two equations. All right, so let's get to the good stuff. Let's actually look at parametrics being used with some calculus. Okay, if you're looking at the textbook, again, we use that Larson textbook. This is from 10.3 now. So derivative of a parametric. If we're given a function of x in terms of t and a function of y in terms of t, then the derivative dy dx is, think when you were doing implicit, okay? It's that everything's in terms of t, so you have to do the derivative of y in terms of t divided by the derivative of x in terms of t. If you move on to do more derivatives, okay, you only ever do the derivative of the numerator, right? So the second derivative would be the derivative of the first derivative over that same denominator, just the derivative of x. The third derivative would be the derivative of the previous, which is the second, over the first derivative of x. You're always keeping that same denominator, and you're only ever redoing the derivative to the numerator. And we have to assume, because it's in the denominator, that we cannot allow the derivative of x to be 0. It would create an undefined issue, okay? So looks a little more complicated with the notation. Let's look at an example. Find the slope of the curve given by x is sine of t and y is cosine of t. To begin with, the wording slope of a curve is some fancy wording for derivative. Okay? Now, because I see two equations, x and y, in terms of t, I know that my derivative, dy dx, is just going to be the derivative of the y function. So I'm going to write some fancy notation here. You don't have to do this extra step. So it's going to be the derivative of cosine of t divided by the derivative of the x, which is sine of t. Okay? Derivative of cosine is a negative sine of t. And derivative of sine is a positive cosine of t. And you're done. If this was the AP test, I'm going to give you a heads up. In the multiple choice, they most probably will not have that because that is an identity from pre-cal, and they will most likely write the answer as negative sine divided by cosine is tangent. So beware for those in those multiple choice sections on the AP test. This next question reads, find the slope and concavity of x equals square root of t and y equals a fourth times t squared minus 4, where time is greater than 0, and we're specifically talking at the point 2, 3. There is a lot to unravel here. To begin with, slope means I'm going to be doing the first derivative, and then concavity means I'm going to be doing the second derivative. Okay? Now, if they gave me this point, this is my x comma y. Notice in the last question, when I did the first derivative, I was in terms of t. So I'm going to have to take a minute and figure out, okay, if this is my x comma y, then what is my t at those points? Okay? Because that is the t that I'm going to be plugging into my first derivative and into my second derivative. So let's take a minute to do that. When I'm at 2, 3, what is my t? Okay, well, let's plug that x and y into these ends of these equations. I can say if 2 is x, then 2 should equal square root of t. And if 3 is y, then 3 should equal 1/4 t squared minus 4. Okay? I think the easiest one to figure out is using the x value. I can isolate that t by squaring both sides and say that t must be 4. Okay? If that's true, it should be able to work here as well. Okay? So I'm going to multiply that 4 to the other side, and I have 12 equals t squared minus 4. Now I can add that 4 over and say 16 equals t squared. And square root of 16 is positive and negative 4. But because on the previous one I only got a positive 4, I am only going to say that I'm using the positive 4. Okay? So now that we found what our t is, I'm going to go ahead and move on and find the first derivative. dy dx is going to be the derivative of y. Remember, you can skip this notation if you start to feel confident. Divided by the derivative of x. And I'm going to go ahead and write this as t to the 1/2 already, make my life a little easier. The derivative of that numerator, I'm going to go ahead and remember you drop coefficients. And then here I'm going to have 2t to the first. Derivative of 4 would be 0. Here my derivative would be half t to the negative 1/2. Okay? If I start doing a little bit of cleaning, this is going to reduce to 2. So then if I have a 1/2 on the top and a 1/2 on the bottom, those are going to completely cancel. So now I'm working with t divided by t to the negative 1/2. Remember that negative 1/2 can come up. So now I have t to the first times t to the positive 1/2. When I have the same base, I add the exponents, and this is like saying 2 over 2. So I have t to the 3 over 2, right? There's my derivative. Now I'm going to do the derivative at 2 comma 3, which is t being 4. So now I'm going to plug that, and I'm going to say 4 raised to 3 over 2. I'm just plugging that 4 into the t. Now remember, when you have a fractional exponent, the denominator is the root and the numerator is the exponent. So it'd be easier to do the square root of 4, which is 2, and then 2 cubed, which is 8. So my slope for this function at 2 comma 3 is going to be 8. That's my final answer for slope. Now let's move on to do concavity. So the second derivative is going to be the derivative of the first derivative, which is t to 3 over 2 over the derivative of the x, which my x was square root of t, which I'm going to write as t to the 1/2, which we already have the answer to that. So I'm going to go ahead and do power rule here, which is 3 over 2 t to the 1/2 divided by, derivative here is half t to the negative 1/2. Okay? So I'm going to go ahead and write this out for you horizontally. 3 over 2 t to the 1/2 divided by half t to the negative 1/2. Okay? So these numbers do a keep change flip, which end up being 3 over 2 times 2 over 1. And then if I'm dividing, I subtract. Okay? So it's like saying half minus a half. Two negatives make a positive, and it becomes a t to the first power. So this can be written as 3t. Okay. Lastly, we're doing the concavity. Specifically, when I am at 2 comma 3, which we found is when t is 4. So now I'm saying this function at 4, which is 3 times 4, which gives me 12. Okay? Now, because my second derivative came out positive, my concavity is concave up. And we are done with this question. For this next question, you're going to need to be confident in your unit circle. So if you need to, pause really quick, take it out from your handouts, or look one up really quick on Google. The question reads, find the equation of a tangent line at 0, 2 for this x function and y function, and you can see that they both have trig functions. So again, the ordered pair is always given to you in x and y. Your first step is going to be to find out what the t would be, okay? So when I'm at 0, 2, what is my t? Okay, we're going to plug the 0 for the x and the 2 for the y. So I could say 0 equals 2t minus pi sine of t. And then my y value 2 is equal to 2 minus pi cosine of t. Now, out of these two equations, the first one has 2 t's and the second one only has 1. So it's probably going to be a lot easier to work with this first one. Excuse me, with this second one. So I'm going to go ahead and subtract this 2 over, leaving me with 0 equals negative pi cosine of t. And then I'm going to go ahead and divide that pi. So 0 divided by pi is still 0. Now, based on my unit circle, I know that cosine is equal to 0 at 2 locations. And that is at pi over 2 and at 3 pi over 2. So I've got two options for t based off of this second equation. Let's go back to the first and figure out which one we're using. I'm just going to test which one of these two would make this statement true. So I'm going to try with the first one. 0 equals 2 times pi over 2 minus pi times sine of pi over 2. Okay? So 0 equals, these 2's are going to cancel and I'll end up with pi minus pi times sine of pi over 2 is a positive 1, which would then leave this pi minus pi, which is 0. So this is a true statement, which means I am going to pick pi over 2. If it didn't work out, you would go on to test the next one, okay? If you did test the next one, you would see that here you would end up with a negative 1, which would start changing this up here and not give you 0, okay? So now that I know my t is, I'm working with an equation of a tangent line. Very, very popular question on the AP test. And that means that you're working with y minus y1 equals slope, which we're going to have to find, times x minus x1. So in this case, the slope is the derivative. So dy dx. Okay, I'm going to go ahead and go a little faster here. The derivative of my y, derivative of 2 is 0 minus, bring down the coefficient, and then derivative of cosine is a negative sign. So I'm going to put the negative, turning this positive, and then put the sign of t over derivative of x. Derivative of 2t is 2 minus, bring down the coefficient of pi, and derivative of sine is cosine. Now we are finding this specifically when t is pi over 2. So now I can say pi times sine of pi over 2. We're going to go to our unit circle for that in a minute. And then 2 minus pi cosine of pi over 2. Sine of pi over 2 is 1. So this is 1 times pi. I'll write it here for you. This is going to be 1. And cosine of pi over 2 is 0. Okay? So that's going to cancel out this whole term. So pi times 1 is pi. And then I have 2 minus 0. Okay? So this right here is my m. It's my slope. And now I'm ready to write my equation of a tangent line. I have y minus my y1 was right here, 2, equals my slope, which is pi over 2, times x minus my x1 is 0. And we can clean this a little bit more and say y equals pi over 2x plus 2. If you're in a free response question, you could leave it at the step before this. If it's a multiple choice, you will be looking for it with the y isolated. For this next scenario, we're going to be looking at arc length of a parametric equation, okay? So the formula reads the integral from a to b of the square root of the x's derivative squared plus the y's derivative squared, okay? And then that integral is going to be done in terms of t. So looking at this example, where they give you the parametric equations of x in terms of t and y in terms of t, and they want you to do this from 0 to pi over 2. Okay, that means I'm going to do the derivative of this x, then square it, do the derivative of this y, then square it, add them together, and then I can do the integral of that square root. And here you have the a to b. Okay, so instead of writing this all in every single time, I'm going to take it one step at a time. I'm going to solve both of the derivatives. Okay, so to begin with, dx dt would be the derivative. This here is going to be product rule. So I have first times derivative of the second plus derivative of the first, the chain rule there, times the second. Okay? And notice that there's a negative in common and an e raised to negative t in both. So I'm going to factor that out, negative e raised to negative t. And then I'm going to have a negative sign and a positive cosine. Okay? I'm sorry, the negative got taken out. So a sine plus a cosine. Okay? So there is my dx dt. Now I'm going to go ahead and do the same thing for the dy dt. I have another product rule here. First times derivative of the second plus derivative of the first times the second. This time I don't have a negative in common, but I do still have the e raised to the negative t. And now I have a cosine minus a sine. Okay. So I just did the two derivatives. Now I'm going to go ahead, draw a little line. I'm going to do the square for each of those. So I'm going to get each of these and I'm going to square them, which means I'm going to do all of this squared and all of this squared, right? And that's literally just me putting the squareds here. Okay, so coming down, dx dt squared. Remember that that exponent of 2 can be distributed when there's a separation of multiplication. So I'm really saying negative e to the negative t squared times, if I square this, let me remind you really quick from algebra. If I have a plus b squared, you can FOIL, but it's a little time consuming. Or you can remember the first term squared plus double the first and the second term being multiplied plus the second term squared, which is what I'm going to do here. It's going to be a lot faster. So if I want to do all of this squared, I can say sine squared plus double multiplying both and then plus cosine squared. Hopefully you are catching that we have a property here with the sine squared plus cosine squared. And this here is going to give me, remember, an exponent to an exponent I multiply. And when I square, a negative disappears. Okay? So I have e raised to negative 2t times sine squared plus cosine squared is 1 plus 2 sine of t cosine of t. And if I distribute that e back in, I have e to the negative 2t times 1, which is itself, plus times this 2 sine cosine, I have e to the negative 2t, 2 sine cosine. And there, I am done doing the dx dt squared. I'm going to do the same thing to the y now. So remember, if I'm going to square all of this, I can distribute that square to both. So I'm going to say e to the negative t squared. And then I'm going to do this rule here instead of having to do the whole foiling. So we have the first term squared times double these two terms multiplied. I have a negative times a positive, so it's going to be minus 2 sine and cosine being multiplied. And then negative sine times negative sine is a positive sine squared. Again, we have this cosine squared and sine squared, which we know from Pythagorean equals 1. E raised to negative 2t times 1 minus 2 sine of t cosine of t. Just like in the last one, I'm going to distribute that e to the negative 2t times 1, and then times that negative 2 sine cosine. All right, so now let me get a red pen just so we can see. This that I cleaned up is this first portion. It's the derivative squared. And this that I cleaned up is this portion, the derivative of y squared. My next step in this formula is going to be to add them together. Okay? So I can say that my arc length is equal to the integral from a to b, which in this case we say from 0 to pi over 2. Now if I combine these, I'm going to have that square root. Let me write this the beginning of the square root there. If I combine these two, they are identical, so I have 2 e's to the negative 2t. And then notice that this term is identical to this term, one positive and one negative, so they're going to cancel out. So this is what I'm left with for my integral. So already this has cleaned up a lot, okay? Now it's just about solving this integral. The first thing I'm going to do is I'm going to separate the coefficient, and I'm going to bring that square root of 2 to the front. And then for the e, I'm going to change the square root as an exponent of a 1/2. So I can say square root of 2 times the integral from 0 to pi over 2. And instead of saying square root of this e, I can say e raised to negative 2t raised to the 1/2. And the reason why I want to do that is because an exponent to an exponent I can multiply. Negative 2 times half is going to give me a negative 1. Okay? At this point, to complete this integration, I'm going to have to use u sub. Okay? So that means my u is a negative t, and it makes my u prime a negative 1. I am missing a negative 1. I can put it in as long as I pull one outside with the coefficient. Now remember, when I do u sub, I need to change my a and my b accordingly. So I could say u at pi over 2 and u at 0. Well, if u was negative t, I would get a negative pi over 2 here, and a negative times 0 is still 0. So I'm rewriting this as negative square root of 2 times the integral of negative pi over 2 and 0. And now I'm saying e to the u du. Okay? Now remember that if the a and the b has the larger number on the bottom and the smaller number on top, I can flip those and take out a negative, or I can solve it as is. Because this is BC, I'm going to go ahead and flip it. It's what I think would be easier, as long as you remember the rule. So, again, I can take out a negative, which would turn this positive. Okay. I can flip these now so they are in order. Okay. And now the antiderivative of e to the u is just e to the u. I'm going to go on to my f of b minus f of a. All right, and then if this is a multiple choice, if it's a free response, I'm sorry, you can stop here. But in case it's multiple choice, you'll probably see that e to the 0 cleaned out, because anything raised to 0 is 1. If it's in a calculator section, they might ask you to put that in. And then you can put the decimal, which I believe gives 1.12. Okay, so again, you can stop here for an FRQ. Multiple choices could look like this in a non-calculator section, or like this in a calculator section. The last topic we're going to be seeing for this lesson is the area of a surface of revolution. Now, back when you learned the application of integration that we did, area revolving, we talked about, if you watch my videos and my silliness, Rolly and White Girl, depending on whether you're revolving on certain things. So even though this is in the form of parametric, and we are going to have two functions, we still have to be careful as to whether the question is telling us that it's revolving about the x-axis or the y-axis. And the formulas differ in one spot only, and that is whether you multiply the g of t, where g of t represents the y function, or f of t, which represents the x function. Okay? So if I revolve about the x-axis, I'm multiplying in the y function as the extra. If I'm revolving around the y-axis, I'm multiplying in the x function as extra. And the rest of the formula is 2 pi times the integral from a to b. And then after we multiply those in, we have the square root of the x's derivative squared plus the y's derivative squared. Let's look at this first example. Let C be the arc of the circle, and they give you x squared plus y squared equals 9, from 3 to 0, and then to 3 over 2, and 3 squared to 3 over 2. Find the area of the surface formed by revolving about the x-axis. What is a little complicated about this question is that nothing is in the parametric form as of now. So what I'm going to show you to first convert the equation, and then I'm going to convert the points, is I'm going to use a method from back in pre-cal, and if you need to refer back to it, I'll show you it here, but in more detail, it can be found in the 9.5 video of pre-cal, okay? So to begin with, I have this function, which is x squared plus y squared equals 9. We learned in that pre-cal lesson that if I can get this to become a 1, remember the Pythagorean identity that sine squared plus cosine squared equals 1, I can then throw those two in the mix and put them in terms of t. So bear with me. I'm going to divide the 9 over, and I have x squared over 9 plus y squared over 9 equals 1. Okay? Now, we remember, so I'm going to put a little like bracket here, that cosine squared of t plus sine squared of t equals 1, right? So that's what I'm going to use to replace the right side, okay? And then I'm just going to separate this left side into two equations. So I can say x squared over 9 plus y squared over 9 equals cosine squared of t plus sine squared of t. Now, I am allowed to write this as two separate equations, okay, which is going to be this one with this one, because remember my unit circle cosines represent the x's, and then this term with the y's with the sine. So I'm going to say x squared over 9 equals cosine squared of t, and I can say that y squared over 9 equals sine squared of t. Okay? Now, I want to isolate the x and isolate the y. So I can move the 9's over. And now I'm going to square root both sides. Square root of 9 is 3, and then it's going to cancel out the squared on the cosine. And that is a method that, again, can be reviewed in the pre-cal lesson on 9.5. So now I have two equations, okay? I have my x in terms of t, and I have my y in terms of t. Now, my next step is to get my ordered pairs, which are x comma y's. This is the beginning and the end of my a to b. I need to just put them in terms of t, okay? So I can say that at 3 comma 0, I need to figure out what my t is. I'm so sorry, I did not scroll as I talked. Take a moment, I'm so sorry. Pause the video, go through that. So here, I put the x squared and the cosine together, the y squared over 9 and the sine squared together. divided the 9, square rooted both sides, and then clean that up. Okay, so again, now we're going to find what the t is at 3, 0. So I'm going to put that 3 as my x, so I can put it right in here and say 3 equals 3 cosine of t. If I divide that 3 over, I say 1 equals cosine of t. And then I'm going to do the same for the next, which means I'm putting that 0 in the spot of this y. Divide the 3. And you're asking yourself, where on the unit circle does cosine equal 1 and sine equal 0? Well, that is at the origin. So that means t is 0. And this is going to be my start, right? Because up here in the given, it said that's where we were starting. So that's going to be my a, okay? So coming back down, I'm going to do the same thing for the endpoint. The endpoint was 3 over 2, comma 3 square root of 3 over 2. And I need to find what the t is. So plug this one for the x. 3 over 2 equals 3 cosine of t. Divide the 3, and I'm going to end up with half equals cosine of t. And then 3 square root of 3 over 2 equals 3 sine of t. Divide that 3 over, and I'm going to end up with square root of 3 over 2 equals sine. So now the question is, where in my unit circle does cosine equal half and sine equal radical 3 over 2? Well, that happens at pi over 3. And that's going to be my endpoint. So here is my a to b. Now that we have my x and my y function and my start to end, I'm going to be ready to set this up. Let's go back up to the top. And now this question said that I'm revolving around the x-axis. So that means I'm going to be saying 2 pi times the integral from a to b, which in this case we saw was 0 to pi over 3, of g of t, which is my y function, which is 3 sine of t, times the square root of, we have the derivative of x, okay, which is going to be a negative 3 sine of t, okay? So again, I had my x function right here, so I just did the derivative of that. And then the formula says to square it, plus the derivative of y, which is going to be a 3 cosine of t, square it dt, okay? So I'm going to pull this 3 out to the front with a 2 pi. I'm going to have 6 pi times the integral from 0 to pi over 3. And now I have sine of t. And now if I square these terms, I have 9 sine squared of t plus 9 cosine squared of t. Hopefully that's looking familiar. I can factor out the 9. Right? We know that sine squared and cosine squared is 1. And I can take this square root of 9, which is really a 3, out to the front. So if this square root of 9 is really a 3, 3 times 6 is going to be 18. And now I have sine of t times square root, sine squared plus cosine squared is 1. 1 times anything stays the same. And now comes the easy part. Antiderivative of sine is a negative cosine. I'm going to bring that negative up front. From 0 to pi over 3. I'm going to draw a line in here just so we don't mess up the left with the right work. And now I have cosine at pi over 3 minus cosine at 0. Cosine at pi over 3 is half. Cosine of 0 is 1. Oh, I forgot my pi. Look at this. Look at me over here. This would be a pi in here. So I end up half minus 1 is a negative half. And so my final answer is 9 pi.